In exercise 1.1, we are going to deal about sequences. So let us see what do you mean by sequences. Now consider the following arrangement of numbers. The first one is 1, 3, 5, 7, 9. So you ought to know what will be the next three numbers or next four numbers. As you can see, 1, 3, 5, 7, 9 are odd numbers. So we can guess that the next number should be 11, and then the next number should be 13, and the next number should be 15, and so on. So all these numbers are in a sequence, which means that all these numbers, they do have some special function or property. One of the special properties that these numbers have is that if you subtract the second number and the first number, 3 and 1, you'll get 2. If you subtract the third number and the second number, you again get a 2. If you subtract the next number with the previous one, you again get a 2. Similarly, 9 minus 7 is also a 2. So in order to guess the next number, we add a 2. So when we add a 2, we get 11. Then 11 plus 2 is 13. And then 13 plus 2 is 15, and so on. So all these numbers are in a sequence. Means all of them show some special property. Now let's look at the next one, which is 1, 4, 9, 16, 25. If you closely observe, 1 is a square of 1, means 1 square is 1. So the first number is the square of 1. While 4 is the square of 2. So 2 square is 4. Similarly, 3 square is 9. So the third number is 9. Then 4 square is 16. The next number is 16. Then 5 square is 25. So all these numbers are perfect squares. Therefore 6 square is 36. 7 square is 49. And so on. So we can guess that the next three numbers should be 36, then 49, then the square of 8, 8 square is 64, then 9 square is 81, and so on. So the special thing that binds all these numbers is that they are perfect squares. So it's not necessary that always there will be a common difference. In this case, you can see there's a special relationship between the numbers. And that special relationship is that all these numbers are perfect squares of all natural numbers. In fact, we can go forward and we can even guess the previous number, which should be the square of 0, which is 0. So in this way we can guess the previous numbers or the next numbers, the upcoming numbers. Now let's observe the next one, which is 8, 16, 32, 64, 128, etc. Now try to figure out what is common thing between all these numbers. That means, why is the next number 32? Why is the next number 32 or 64, 128 or and so on? As you can see, the first number is 8. The next number is the double of 8. So if you multiply a 2, you get 16. Then if you multiply a 2 again to 16, we get 32. If you multiply a 2 again to 32, we get 64. So the next numbers are 2 times the previous number. So we can say that the second number is 2 times the first number. Or in other words, the second number, T2 means the second number or the second term, is 2 times the first term. It is 2 times the first number. So we can guess the next three numbers or whatever you want to. So we can guess the next number should be 128 multiplied by 2. That is 256. The next number would be 256 multiplied by 2, which is 512, and so on. We can guess the other numbers also. So in this particular scenario, we can say that the next number is 2 times the previous one. It's the double of the previous one. In this case, in the next one, 11, 15, 19, 23, 27. If you subtract 15 and 11, you get a 4. If you subtract 19 and 15, you again get a 4. 23 minus 19 is also a 4. 27 minus 23 is again a 4. So all these numbers are also in a sequence. That is, they have a common difference of 4. So the next number should be 4 more than 27. So the next number should be 27 plus 4, which is 41. The next number should be 31 plus 4, which is 35, and so on. In fact, whenever you come across a common difference of 4 or 2 or whatever, it is also known as arithmetic progression. Means all these numbers, they are not only a sequence, but they are also a progression. And that special progression is called arithmetic progression. Look at the next number: 100, 95, 90, 85, 80. So if you subtract 95 and 100, you get a negative 5. If you subtract 90 and 95, you again get a negative 5. 85 minus 90 is negative 5. Remember, we subtract the second number and then we take the first one. It's like this. It's 95 minus 100. It's minus 5. We never take the first number minus the second number. We never do this. We always take the second number, which is term 2, and we subtract the term first. And in this case, we see that it is always the same. It is minus 5. So this is also a sequence. We can guess the next number would be 75. 75 minus 5 is 70, and so on. So again, this is not only a sequence, it is also an arithmetic progression. It is also an AP. So we can deduce that a sequence is a collection of numbers arranged in a definite order according to some definite rule. Now let us learn how to solve such sums. The question is, for each sequence, find the next 4 terms. And the sequence is 1, 2, 4, 7, 11. So you need to guess what should be the next term. So let us try to analyze this. If you subtract the second number and the first number, you get a 1. Then if you subtract 4 and 2, you get a 2. You don't get the same thing. Subtract 7 and 4, you get a 3. Subtract 11 and 7, you get a 4. So at least you can see there is a common connection. And the common connection is that if you subtract the next number from the previous number, you get 1 first, 2, 3, 4, and then maybe you'll get a 5, then you'll get a 6, and then you'll get a 7, maybe. Okay? So the connection is that the next number, which we don't know actually, should be 5 more than 11. So the next number should be 16. And then its next number should be 6 more than 16, which is 16 plus 6 is 22. And then it should be 7 more than 22, which I hope is 29. And then it should be 8 more than 29. So 9 plus 8 is 17, 47. So the next 4 numbers are 16, 22, 29, 37. How do we write this? So we'll write that the first term T1 is actually 1. Then the second term T2, the second number T2, is the first number plus 1, and that is 2. Then the third term T3 is this 2 is taken down, and then we add the next natural number, which is 2. The first natural number was 1, the second natural number is 2. So we get 2 plus 2 is 4 as expected. Then T4 is, we take the previous number 4, which is this one, and then we add the next natural number 3. You can see 1, 2 and 3. So that makes it 7. Then in order to find the fifth term, we take the 7 and then we add the next natural number 4. So 7 plus 4 is 11. This is how we write in the exam. So T6 should be, we take the previous number 11 and then we add the next natural number 5, which is 16. So this was our first part, first answer in fact. Then in order to find the seventh number, or the seventh term, T7 means seventh term, we take the previous term and we add the next natural number 6, which is 22. Then in order to find the eighth number, we take 22 and we take the next natural number 7 and we get a 29. And T9 is 29 plus the next natural number 8 and we get a 37. So in this way we get the next 4 terms. We can find next 5 terms or 6 terms also. Now take this example, 1, 3, 7, 15, 31. So we are told to guess the next 4 numbers. So what are the next 4 numbers? So if you analyze this also, if you subtract 3 and 1, you get a 2. If you subtract 7 and 3, you get a 4. If you subtract 15 and 7, you get an 8. You can see the differences are though not common, but the double of 2 is 4 and the double of 4 is 8. So we can expect that the next difference should be 16. Yes, 31 minus 15 is in fact 16. So accordingly we can say that the next difference would be the double of 16, which is 32. So if you add 31 and 32, you will be getting a 63. And then the double of 32 is 64. And 63 plus 64 is 127. Then you add 128, which is double of 64. In fact, you notice carefully, it is just one more than 127. 128 is one more than 127. 64 is one more than 63. 32 is one more than 31. So that is also another connection. So if you add them, 8 plus 7 is 15. It's 255. And then if you add 256, you will get 511. So the next 4 numbers are 63, 127, 255 and 511. This is one of the ways to do the sum. Another way is just if you see carefully, you add one more to 11, to 1, you get a 2. If you add one more to 3, you get a 4. If you add one more to 7, you get an 8. If you add one more to 15, you get a 16. If you add one more to 31, we get a 32. So the next number should be 64 minus 1, which is 64. The double of 64 is 128 minus 1 is 127. The next number should be double of 128, which is 256 minus 1, which is 255. And then 512 minus 1, which is 511. So we can write it in any way that we like. So in the exam you need to write that T1 is equal to, and we'll write a 1 over here. T2 is equal to, and we'll write 3 over here. Then T3 is equal to, and we'll write 7 over here. But we know that the 7 is nothing but 2 cubed, which is 8, minus 1. Of course, 8 minus 1 is 7. Similarly, this 3 is 2 raised to 2, which is 4, minus 1. And similarly, 1 is nothing but 2 raised to 1, which is 2, minus 1. So in this way, we can guess the other numbers. So T4 is 2 raised to 4. See the connection? When we want to find the fourth number, fourth term, we raise the 2 by 4. Minus 1. So that will give us 50. 2 raised to 4 is 16. 16 minus 1 is 50. In the same way, T5 is equal to 2 raised to 5 minus 1. So we'll get a 31. And same way, the first answer is 2 raised to 6 minus 1, which is 63. And T7 is 2 raised to 7 minus 1, which is 127. Then T8 is 2 raised to 8 minus 1, which is 255. And T9 is 2 raised to 9 minus 1, which is 511. So in this way we need to write in the exam. Let's check the next four numbers over here. As you can see, it's a very simple one. The double of 2 is 4, the double of 4 is 8, the double of 8 is 16. So we can guess the next number should be 32, then the next should be 64, the next should be 128, the next should be the double of 128, that is 256. So we can write T1 as 2, T2 as 4, T3 as 8. You can observe that this is 2 cubed, this is 2 squared, this is 2 raised to 1. So T4 should be 2 raised to 4, which is 16. Then the fifth term, the first question, is 2 raised to 5. This time we are not subtracting the 1, it is 64. Then T6 is 2 raised to 6, which is 64. In fact, this is 64, this was 32. And T7 is 2 raised to 7, which is 128. And T8 is 2 raised to 8, which is 256. Now let us understand how to solve this question. Find the first 5 terms of the given sequence. Means we need to find what is T1, T2, T3, T4 and T5. Means the first 5 numbers. T1 stands for the first number, T5 stands for the fifth number. And the formula given is Tn is equal to 4n minus 1. So in order to find the first term T1, wherever you see n, substitute n is equal to 1. So this will be 4 into 1 minus 3. So 4 into 1 is 4, 4 minus 3 is 1. So the first number is 1. Similarly, T2 is equal to 4 into 2 minus 3. Just substitute n is equal to 2. 4 2 is 8, 8 minus 3 is 5. So as you can see, the difference is 4. 5 minus 1 is 4. T3 would be 4 into 3 minus 3, which is 12 minus 3, which is 9. Again, the difference is 4. So we can say that this is not only a sequence but also an arithmetic progression with a common difference of 4. And T4 is 4 4 minus 3, which is 16 minus 3, which is 14. And T5 is equal to 4 into 5 minus 3, which is 20 minus 3, which is 17. So the first 5 numbers are 1, 5, 9, 13 and 17. They are not only a sequence but also an AP. Now, let us understand this. Suppose the first numbers of the sequence, not necessarily AP, are 1, 3, 5, 7, 9, etc. Let's say odd numbers. Or this is AP with a common difference of 2. So T1 is 1 while T2 is 3, term number 3 is 5 and so on. But if I say S1, it means 1. S stands for sum. Sum of the first number, which is the first number itself. If I say sum of the first 2 numbers, it means the first number and the second number added together. So 1 plus 3 is the sum of the first 2 numbers. If I say S3, this is the sum of the first 3 numbers. So the first number is 1, the second number is 3, the third number is 5 as you can see above. So 1 plus 3 is 4 that we already got. 4 plus 5 is 9. And then in order to find the sum of first 4 numbers, we take 1 plus 3 plus 5 plus, we take the next number 7. And as we know that 1 plus 3 plus 5 is 9, so just add 9 and 7, you'll get a 16. So S4, sum of 4 numbers is 16. Similarly, sum of 5 numbers is 1 plus 3 plus 5 plus 7 plus The next number is 9, and 16 plus 9 is 25. Now, observe carefully. If you subtract 25 and 16, you get 9, which is this number 9. If you subtract 16 and 9, you get a 7, which is this particular number 7. If you subtract 9 and 4, you get 5, which is in fact this particular number 5. And if you subtract 4 and 1, you get a 3, which is this particular number 3. So in other words, if you subtract the sum of the first 5 numbers and the sum of the first 4 numbers, you get what? The sum of the first 5 numbers is as 5, the sum of the first 4 numbers is as 4, and if you subtract, you get a 9, and this 9 is actually this particular number 9, which is nothing but this particular number 9. Okay? And this particular number 9 is the 5th number, so you get term number 5. This is always true. If you take the sum of the first 3 numbers, if you subtract the sum of the first 2 numbers, you get the 3rd number. As you can see over here, sum of the first 3 numbers is 7, sum of the first 2 numbers is 5. Subtract them, and you get 9 minus 4. Subtract them and get a 5, and this 5 is this particular 5. So in general, we can generalize this formula as follows. The sum of n numbers minus the sum of n minus 1 number is nothing but the nth term. So this is a very, very important formula. Not only this, we also realize that the sum of the first number is nothing but the first number itself. So T1 and S1 are always equal. So that is another thing that we come to know. T1 and S1 are always equal. In fact, we also denote this by a letter A. A means the first term. So this is another thing that we come to know. Now let us understand this with the help of an example. Suppose if we are given that Sn is equal to n squared into n plus 1, and if we are asked to find the first 3 terms, means find what is T1, T2 and T3. So let us see how to find it. So first of all, we are going to find what is S1. So S1 is nothing but 1 squared into 1 plus 1. Means we are substituting n is equal to 1. So it is 1 squared is 1, 1 plus 1 is 2, 1 2 is 2. So S1 is 2. Similarly, S2 is equal to 2 squared 2 plus 1, which is 4 into 3, which is 12. And S3 is equal to 3 squared. Remember, n takes the value of 3. Again over here, 3 plus 1 is equal to 9 into 4, which is 36. So as we know that the first term is nothing but the sum of first term, which is 2 itself from here. And in order to find the second term, what we do is we take the sum of the first 2 numbers minus the first number itself, which is 12 minus 2, which is 10. Simply speaking, this is 12 minus 2. So the second number is 10. T3 in the same way is S3 minus S2, which is this 36 minus 12. It's 46 minus 12, which is 24. So the first 3 numbers are 2, 10 and 24. Thank you for watching.